Direct variation, folks. Okay, direct variation. And I'm just trying to untangle this crazy town craziness. Okay, so direct variation. And I'd like you to write this down, the equation y equals kx. And you're thinking, what is y equals kx? Well, we are, in the equation of a line, we have our slope-intercept form, which is y equals mx plus b, okay? And I want you to know, okay, basically that y equals kx, which represents a direct variation where y varies directly with x, is very similar to our slope intercept form in that instead of our b, okay, our y-intercept is always going to be 0, where the line always crosses over the y-axis at 0. So if you look down here, these are the two graphs of direct variations. I'm trying to show you the graph and explain the formula at the same time and show you the similarity, okay? So again, direct variation y equals kx is very similar to slope-intercept form y equals mx plus b, where, okay, the y-intercept, the b, will always be 0, so the line will always cross over the y-axis at 0, 0. As you can see here, it's crossing through the origin at 0, 0, and this one is also crossing through the y-axis at 0, 0. And basically, instead of your slope, okay, we're going to name the slope your k. It's still your slope, but we're renaming it k, and k means the constant. Okay, so I'd like you to circle that k and write the word constant. Constant meaning, like if you say the word constantly, okay, the word constant means it has to be the same number. K has to equal the same number every single time in order for this to be a direct variation. You can't have different numbers for K. So if you have, let's say you have y equals 5x, okay? Your constant is 5. Okay, your slope is 5. It doesn't change. It's not going to be 5 and then 6 and 7. No, it's 5x. It's your constant every step of the way. That's how you determine a direct variation where y varies directly with x if your constant is the same. So we're gonna talk about that. Now, if you, and since the constant, your k, is so important, we need to know, well, how do we find out what the k is? Well, you're just going to take your direct variation, okay, formula and solve for k. Because if you want to know what k is, solve for k. How do we do that? Well, circle the k. If you want to get the k all by itself, right, you're going to divide by x, the x's cancel, and k equals y divided by x. So if you ever want to find out, and you're going to see that in the future here, if you ever want to find out what is your k, what is your constant, okay, all you need to do is take your y divided by x, and that tells you your constant, okay? And if it turns out to be the same number every time, then you can say, yes, this in fact is a direct variation, okay? So moving on. So again, here are the graphs. I'm going to scroll it down. Here are what the graphs of a direct variation looks like. Again, you know, like I said, it always passes through 0, 0 because you have y equals kx, you know, and there's no plus b, like we said. So it's always 0, okay? So as you can see, those two graphs are of direct variations are passing through 0, 0, and they are linear, okay? Linear equations. Circle the word line, okay? Line R, linear, okay? Lines, linear equations. All right, moving on. Direct variation. So the slope is K. We said that. All right, moving on. How do we identify? Okay, I'm going to try and make this a little bit easier. Excuse me, bigger. There we go. Okay, so how do you identify an equation that is a direct variation? Well, we know that the direct variation formula is y equals kx. Circle it, bubble it, put the star and the smiley face, you know, as per usual. Okay, so if it doesn't, please listen to me when I tell you this. If it doesn't look like this, if it doesn't look like y equals kx, it is not a direct variation. So they may ask you, does this equation represent a direct variation? Dudes, people, ladies and gentlemen, there you go. Does this equation and does this equation, okay, they're asking you for both, represent a direct variation, okay? If so, find the constant of the variation, okay? So, meaning, no matter what they give you here, okay, you have one step, folks, okay? Solve for y. Everybody write solve for y, okay? That's all you got to do. Yup, that's all you got to do. Because if it doesn't say y equals kx, okay, then it is not a direct variation. So you're going to get questions where they're going to give you an equation, and all you have to do, one step only, okay? All you have to do is solve for y. And if it winds up looking like this, y equals kx, you have a direct variation. If it doesn't look like this, no. The answer is no. So let's take a look here. We have 7y equals 2x. We have to solve for y, right? That's the only step. So what is the only step we have to do here to solve for x? Well, that would be divide by 7 on both sides, and we have y equals 2/7 x. Does this look like y equals kx? Yes. Therefore, yes. This is a direct variation, okay? And what is the constant, people? The constant. The constant is the k. It says, if so, find the constant of the variation. Well, hello. Y equals kx. 2/7 is your constant. Pretty simple, okay? Go for it. Go ahead and solve for y in B, and you tell me if that is a direct variation, okay? What is the only step we have to do? Solve for y. Circle it. Circle a y, okay? So we need to subtract 4x and divide by 3. Subtract 4x. 3y equals -4x plus 8. Ding, ding, ding. I think there should be some things, you know, buzzing in the brain here, folks, already based on, you know, what we can see here. Divide by 3, divide by 3, divide by 3. Okay, y equals -4/3 x plus 8/3. Okay, here's our answer. Does this equation even, does it look like y equals kx? No. Okay, no. Therefore, this is not a direct variation. What was the dead giveaway? Hello. 8/3, okay? A direct variation does what? it crosses over the y-axis at 0, 0. We don't have a y-intercept with direct variations. And the fact that we had a term here was a dead giveaway, okay? So moving on. All right. So that is how you identify a direct variation given a particular equation. All right. Now, scrolling down, we're going to write a direct variation. Writing a direct variation. I love how this is explained because it is so super simple, okay? I want you to writing a direct variation equation, okay? It says, suppose, there it is again. Suppose y varies directly with x. You guys, I don't care what you have to do, but when you hear, y varies directly with x, well, they even say the word direct, okay, in that phrase. They say the word direct in the phrase. Suppose y varies directly with x. Okay, so it should be y equals kx. This is our direct Suppose y varies directly constant with x. Okay, that is your clue, your hint that we're talking about direct variation. Okay, so suppose that it does. So suppose we do have a direct variation. We would like you to write the equation. So they're telling you what y is equal to, all right? And they're telling you what x is equal to, all right? They're telling you the y and they're telling you the x. What direct variation equation relates x and y? It's just basically saying, write that equation. Well, here we are. Start with writing y equals kx. And I always say, what? Rewrite it with the empties, right? Empty equals k empty, right? What did they say that y is equal to? 35. What did they say that x is equal to? 5. Okay? So here you are. I'm showing you now. All right? And then what do we have to do? Solve for k, right? So divide by 5 on both sides. And k, 35 divided by 5 is 7. K equals 7. All right? So so what is our equation? Now that we know what the constant is, we know what the k is in our y equals kx, right? Now that we know what the k is, we can write the equation, we can write the direct variation, which is y equals 7x, okay? Because the k is equal to 7. So we're going to substitute our constant, okay, in for k. So here we go. We have y equals 7x. This is our equation, y equals 7x. How did we do it? Step 1, write the formula y equals kx. Step 2, rewrite it with the empties, okay? Plug in your x and your y and solve for k. Here we are, we solved for k. Then you write your direct variation equation, y equals 7x, which is what we have over here. And then it says, what is the value of y when x equals 9? Okay, well, they're telling you, we wrote our direct variation equation, okay? And now they're asking you, what is the value of y when x is equal to 9? Well, what do we have to do? Substitute, right? Y equals 7 empty, okay? And they're telling you that x is equal to 9, so let's put 9 in there. And then y equals what? 63, and you're done. That's it. Okay, so when it says, suppose y varies directly with x, you know for certain that you're dealing with a direct variation, and we have to use y equals kx and go from there. All right, and let's do the next example here together. Let me scroll it down for you. Okay. Suppose y varies directly with x. There it is again, people. Oops. Sorry, I'm trying to move. Okay. All right. Suppose y varies directly with x. Always, 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 people. Okay. Write the formula. Rewrite it with the empties. Okay. And y equals 10 and x equals -2. Okay. What direct variation equation relates x and y? So we have to solve for x. Okay. Well, let's do the math. 10 equals k times -2 is what? -2k. And then we have to solve for k. How do we do that? By dividing by -2 on both sides. And k equals -5. Here's our k. So step 1, solve for k. Step 2, all right, put it in your direct variation, okay? Y equals -5x because our k goes here, right? K, right? K is equal to -5. Now it says, what is the value of y when x equals -15? Well, another substitution. Oh my gosh. Okay, a negative times a negative gives you a positive. And 5 times 15 is what? Well, 4 times 15 is 6. Okay, so we have 75. Y equals 75. I got a little nervous there. Could you see me sweating? Okay, moving on. So you're going to have questions like that in your assignment and on the EOC. Direct variation is very popular on the EOC. And but we have to be able to look at it in different ways. So let's take a look at it on a table. Okay, let's take a look at it here. Now, what did I tell you was the situation? Oh, I'm sorry. I'm not looking at what I'm doing. I'm thinking it looks the same. There we go. Okay. So, I don't have a calculator up here. Okay. But basically, you're going to see it in a table at like this, and they're going to ask you, let's write it again, okay, y equals kx. And the only way that both of these tables can be considered direct variations is if the k, okay, is constant. It's the same every single time, okay? And so how do we solve for k? Well, we divide by x on both sides, okay? And k equals y divided by x. Here it is. So with the table, you're going to take your y and divide it by x. And if you get the same number every time, then you can say, yes, this is a direct variation, or no, it's not, depending on what you get. So for the next 3 tables, we'll go through that live, okay? So again, with the tables, all you have to do is take the y and divide it by your x, and if you get the same number every time, it's a direct variation. Let me show you the next example, okay? Here we go. So for the data in the table at the right, does y vary directly with x? In other words, remember, direct. When you hear that phrase, it's asking you, is this a direct variation? If it does, write an equation for the direct variation. So we'll go over that live. First of all, we have to see if This is a direct variation. You know, k equals y divided by x. And if it's the same every time, then yes, we have a direct variation, and then we will write the equation. Okay, so we'll go over that live. Okay, so now a word problem comparing, we're going to compare, we're going to graph, okay, graphing a direct variation, okay, talking about weight on Mars versus, you know, the weight of the Earth, or, you know. So it says weight on Mars y, okay, they're telling you that Mars is the variable y, so let's write y equals kx, okay? So you can say that, you know, y is Mars, weight on Mars y varies directly. It's telling you it's a direct variation. It's telling you that it is, okay, with the weight on Earth x. So, you know, Mars is y, x is the Earth, okay? The weights of the science instruments on board the Phoenix Mars lander on Earth, you know, is shown here. So weight on Mars is 50 pounds and the weight on Earth is 130 pounds. Okay, so which equation, what is an equation that relates the weight in pounds, okay, on Earth and the weight on Mars y? Okay, so that's what we're going to be step by step going through. So take a look here. Write your equation y equals kx. Let me scroll it down a little bit. Okay, y equals kx. So again, you know, and rewriting it with the empties, right? So, you know, we said that y was Mars. Mars is y, so that's 50. Okay, right here, 50. And then substituting in, so because I always rewrite it with the empties. Okay, and then if you actually do the division, divide by 130 on both sides, okay, your k is equal to this, 0.38. Your constant is 0.38, okay? And then you have to write it in y equals kx form, okay? You know, what is an equation? What is the equation? Well, now that you know what the constant is, you can just fill it in for k. Y equals 0.38x, okay? You wrote your equation. All right, now we're going to take it a step further. Moving on. Let me show you the table. What is the graph? Okay, what is the graph? You have to be able to look at this table here, okay, and relate it to the graph. Well, first of all, we all know that this is a direct variation. What is the dead giveaway? It goes through 0, 0, okay? And it's a positive slope. And so when 0 is x, your y, when x is 0, your y is also 0. That makes sense because you're just plugging in for y each time, okay? And when your x is, let's write the equation again so this makes sense to you. It's going to be, let me write it here, y equals kx, okay? So, and we said that your k is equal to 0.38, okay? So, you know, every time that you multiply the x value, okay, when you multiply this by 0.38, it's going to give you your y, okay? So 0.38 times your x value gives you your y. So when x is 0, Well, 0.38 times 0 is 0, so your y is 0. That's how we got this 0.00. Do it again. Okay, when your x is 50, okay, when we put 50 here, 0.38 times 50 is 19, okay? So when x is 50, go to 50, your y, go up to 19, is right here. That's your next point, okay? And when your x is 100, well, 0.38 times 100 is 38. So when your x is 100, your y is 38. And when your x is 150, okay, take your constant, which is 0.38, multiply it by 150, it gives you 57. Okay, and then you connect the dots, and that's how we got the points on the graph. What I want you to know is that the constant, the dead giveaway, that this is a direct variation, is the 0.38, 0.38, 0.38, 0.38. When the constant is the same every time, you know you have a direct variation. Okay? So we will have questions like this on our assignment, and as always, you can always stop, rewind, and go back and recheck.